Hello 8th graders, this is Mr. Humphreys and we're going to start proofs. Now there are two types of proofs, algebraic and geometric. We're going to go over both of them, but I first want you to write down the definition of a proof. A proof is an argument that uses logic, definitions, properties, and previous proven statements to show that a conclusion is true. This next part of the video, I don't want you to write anything down. You are more than welcome to, but I would rather you just listen and understand what we're doing. So we're going to start with an algebraic proof. Now, if you've ever solved an equation, which you all have, in algebra, you've solved many equations before. So let me just write down an equation such as -5 equals 3n plus 1. You do not need to write this down. You know how to solve this. Now, obviously, most of you probably just move the 1 over and you write -6 equals 3n. You divide by 3 and you put n equals -2, which there's nothing wrong with that. Believe it or not, that's a proof. It's an algebraic proof. What an algebraic proof is that it uses algebraic properties such as the properties of inequality and the distributive property. You've used proofs before, but you just do it. Here's the problem. What you're going to have to start doing in a geometric proof is showing all those steps again. Now, you're not going to actually show an algebra problem per se every time, but you're going to have to prove to me what you're going to be doing in a geometric proof. So let me enlarge the picture here, because I know you can't see it. But this picture, which I would highly suggest you earmark this page, or somehow you can, my suggestion would be pull it up online, make a screenshot of it, and put it into your Google Drive so you can put this with your proofs maybe, or you can write these down. Most of these should be fairly common sense though, since you've used them all before. So if you're looking at this, when you add something, just like in an equation, when you add something to both sides, you use the addition property of equality. Subtract something on both sides, subtraction property of equality. If you multiply something on both sides, you get multiplication property, dividing, etc. Reflexive, that means something is equal to itself. Symmetric means that you can write A equals B and B equals A. Transitive says that if A equals B and B equals C, then A equals C. And substitution is when you take something and plug it in for something else. So I'm going to minimize this again. And let's go through and write the reason next to each of these steps. You don't need to write this down, I just want you to listen. So in the very first step, obviously we subtracted 1 on both sides. So the first part of the equation, it's the given. So we're going to call that our given. Then we're going to write subtraction property of equality. You're going to notice, and you're going to love doing this, you're going to abbreviate almost everything. As long as I know what you're doing and we can tell, you obviously can abbreviate angles. You can abbreviate congruent for a symbol. Any of that stuff is fine with me. And that's something that you'll do in high school and throughout college. So the next step, what do we do? Well, we simplified. The next step is dividing both sides by 3. So that's division property of equality. And once again, we simplify the problem. The last thing we should do is write it as n equals -2. That's something that most of you don't do, and there's no reason to. But when we're doing proofs, we would actually write n equals -2. We flipped it around. And that would be symmetric property of equality. So that's an example of an algebraic proof. Now, you've done this, you've never probably written all the steps before, and right now you're able to skip steps, which is perfectly fine. But now we're going to go into geometric proofs. So let's start talking about a geometric proof. I want you to think back with what we were talking about with logic statements. You guys know already that a conjecture involves a hypothesis and a conclusion. You have something you're starting with, and you have to conclude that it's true. So what you're going to do is you're going to start with a hypothesis. You're going to use or create a chain of logistical steps in which you've used deductive reasoning. You're going to move from the hypothesis to the conclusion, which is your final step, by proving your steps in between. And you can use anything from definitions to postulates to theorems to properties. When writing a proof, it is important to justify each logical step with a reason. You can use symbols, abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. Now, when we do proofs, we're going to start with two-column proofs. Two-column proofs are when you have two columns. In the left is our statements. Whoops, let me write that correctly. And on the right, you're going to have your reasons. And you're going to number them 1, 2, 3, 4 on both columns. Now, you may have 3-line proofs, you may have 8-line proofs, but you are going to be using things you've already proven as reasons behind them. So let me just kind of show you an example. You're more than welcome to write this down. But the first one, if you just want to watch, that's fine. All right, so here's an example. You are always going to be given a given and what you need to prove. So in this problem, it says that ray NP bisects angle MNQ. The measure of angle MNP is equal to 6x minus 12, and the measure of angle PNQ is equal to 4x plus 8. Prove that the measure of angle MNQ is 96 degrees. You've done already this problem before. I took it off your study guide from chapter 1. So in this problem, the first thing I would suggest you do is draw a picture and set up your proof. All right, so I drew my picture, and I drew my T-table, my two-column proof. One on the left says statements, the column on the right says reasons. The very first thing you're always going to do is basically restate the given. So I recopied what the given is, and your reason is that it's the given. Your second step, now here's the problem, and I'll tell you right now, gifted students have problems with this because it's just so, you just know what to do. You know that this angle here and this angle here, you're equal. So you know you have to set those two things equal, but you can't. You have to prove to me, how do you know it's equal? So what you'd have to do is this. And I'm going to warn you, you're going to get annoyed by this because you're going to say to yourself, I already know how to do this. But this is a geometric proof. You're going to have to start off by saying that angle MNP is congruent to angle PNQ. Why are those two angles congruent? Because, back on page 23, you learned the definition of what? Angle bisector. And we can abbreviate. What did the definition of angle bisectors say? They said that if you cut an angle bisector is a ray or a segment or something that cuts an angle into two congruent pieces. Notice I didn't say equal. We said congruent because that's what the definition states. This is why you need to know your definitions. If you don't know your definitions of postulates, this is hard. The next step is 3. We then have to say that the measure of angle MNP is congruent to the measure of angle PNQ. Now you're like, that's the same thing. No, it isn't. The first one says that the angles are congruent. This is saying that their measures are equal. So what did we use? We used the definition of congruent angles. Now you'll get better at these. I mean, once you start using them, you'll understand where you need to use them, so you will get better. But what a definition of congruent angles said? It said congruent angles have the same measure. Now, being that we know that this angle and this angle are equal, we take step 4. I know you're loving this. And we're going to say that the measure of angle MNP, it's 6x minus 12, is equal to 4x plus 8. Why? How'd you do that? You used substitution. Substitution says we're plugging something in, because right up here it said that this is equal to this and this is equal to this, so we can use substitution. Now you're going to solve your equation. Every single line has to be something different. We're going to run out of room here, but that's okay. So the first step is that we're going to have, we have to subtract 4x on both sides. And if you subtract 4x, you're going to get 2x minus 12 equals 8. What did we use? We used subtraction property of equality. The next step, 6, we have to add 12 to both sides. So you get 2x equals 20. Why'd we do that? Because it's addition property of equality. 7, divide both sides by 2. We used division property of equality. What do you do now? Remember, your last statement is always going to be what you have to prove. So 8, you're going to say that, now there are different ways to say this, but I'm going to say the measure of angle M and P, because that's what we, I'm sorry, M and Q is what we need. So we need to find M and P equals 6 times 10 minus 12. And we can say the measure of angle P and Q is equal to 4 times 10 plus 8. And each of these, that would be 60 minus 12. 60 minus 12 is 48. And that's degrees. 4 times 10 is 40 plus 8 is 48 degrees. What did you do here? You use substitution property. Now I've run out of room, so I'm going to go to the next slide here. All right, so step 9, I know you just want to write down, well, we know it's 96. Well, what you have to say now is that the measure of angle MNP plus the measure of angle PNQ is going to equal the measure of angle MNQ. Now, how do you know that? If you add two angles together, it gives you the bigger angle. What do we use? The angle addition postulate. This is why you're going to be writing this stuff down in a separate part of your notebook, because you're going to have to recall what these are, or make flip cards, or a flip chart, or something on Google Docs. But you have to really, really look at these. Next step, 10. 48 degrees plus 48 degrees equals 96 degrees. Whoops, that's not an equals there. Let me erase that. So step 10, what did you use? You use substitution. And finally, we can say the measure of angle MNQ equals 96 degrees because of transitive property. Because all of this equals the measure of angle MNQ, and 48 plus 48 equals 96. So therefore, the measure of angle MNQ has to equal 96 degrees. Now, you're not going to have 11-step two-column proofs right off the bat, but I wanted to give you an idea of what you're in for. And while these steps are not hard, the reasons are hard. It's hard to know what the reasons are. It's also hard to not skip things, because you're thinking to yourself, really, I have to do all of this for a problem I already know how to do? The answer is yes. So you'll practice, you'll get better at this. Example 2, I do want you to write down. Given angle 1 and angle 2 form a linear pair, I want you to prove that angle 1 and angle 2 are supplementary. So the first thing we do is we write our two-column proof. So we have statements and reasons, and I'm just going to write down the given. So after I write my given, which says angle 1 and angle 2 form a linear pair, we go to the next part. I guarantee that if you're given that something is a linear pair, you have to know the definition to a linear pair. The definition of a linear pair, if you don't remember, states that a linear pair of angles is a pair of angles that are adjacent whose non-common sides are opposite rays. So, because we have opposite rays, we can say that ray BA and ray BC form a line. Why can we say that? Because that's the definition of a linear pair. Now, what do you know from a line? You go one step. It's like a chain event. One step to the next. It's linked together. Because you formed a line, what do we know about a line? We know about a line that the measure of angle ABC, which is a straight line, is 180 degrees. How do we know that? How do you know that that's, use common sense here. How do you know that's 180 degrees? Because of the definition of a straight angle. Because right here we're saying the angle is 180 degrees because we know a straight angle is a line, which is 180 degrees. Step 4. Step 4, let me write that down here. This is where it gets tricky. You have to figure out something about showing that this is a straight line, 180 degrees, but angles would have to add up to give you 180. So we somehow have to add angles together to give you 180. Well, since we're adding angles together, the angle addition postulate is going to come in incredibly handy. So we have to first say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. Remember, we just proved that ABC is 180 degrees. What do we use? The angle addition postulate. Step 5. We know what? We know, this is what you just told me, this is where you really have to look. We said that the measure of angle ABC is 180. The measure of angle ABC is 180. Here's ABC. So then you can say the measure of angle 1 plus the measure of angle 2 is equal to 180. What did you do there? You used substitution. And 6, because you know those two angles add up to 180, we can say angle 1 and angle 2 are supplementary. Why? Because of the definition of supplementary angles. Supplementary angle says we have two angles whose sum is 180 degrees. So that would be your proof for this problem. Now let me just tell you that this is something that you will get better at. Most students find this very difficult, and that's okay. We will get through this, but we have to work together because this is going to be challenging for most of you, and that's okay.